middle, evaluating large language models in dispute resolution. My name is Jinzhe Tan. I'm a PhD student from University of Montreal and research assistant at Cyberjustice Laboratory. Of course, we have a lot of amazing co-authors here, act as writers, annotators, and evaluators. I'm very grateful for their contribution. So let's go to the content of today's presentation. First, I'm going to introduce the problem we notice in the field, and then we are going to introduce the proposed framework and the experimental setup, then the result, and some discussion about the key takeaways and limitations. First, introduction. There are many disputes happening in the world everywhere, but dispute parties may be overwhelmed by emotions, or they find it's difficult to communicate with each other. They struggle with complex situation. They might be misunderstood or confused with each other, or there just lack of evidence that both parties are arguing for different facts. So intermediaries, like mediators, arbitrators, or consolidators, they can calm the tension among the dispute parties. They can help the parties to find out what is really going on in disputes, identify key issues, clarify misunderstandings, and hopefully propose some acceptable solutions for both dispute parties. But the challenges, of course, exist in this area. The first one is restricted accessibility. The dispute have certain values. If we want to use mediators to help solve the dispute, at least the value of the dispute has to be higher than the value of the mediator, otherwise it's not worth it. And there are also resource constraints. There is just lack of enough well-trained mediators. So there are attempts to use technology to help to facilitate this process. In 2001, there's been a theoretical method to solve family disputes. So it's like two parties propose different offers, and hopefully the offers can get closer and closer to each other. At the end, hopefully they could reach a solution. And there are also computational methods as described by Lassen in 2010, and by a paper by Carl Branting, this computational method for online dispute resolution. So it's like standard, the system is providing standard messages to help the dispute resolution on online platforms. So after large language models came out, we are thinking about whether we can use large language models to resolve like dispute among dispute parties. So we are using the AI mediator framework. This is a framework proposed by Hannes, Jaromír, and Karim in last year. The title of the paper is AI mediator GPT-4 assisted online dispute resolution. Within the AI mediator framework, there are mainly three functions. The first one is help the dispute parties to reformulate their message, like to calm down the tension in the message or the curse word they are using in their message, so that it hopefully help the dispute parties to solve their problem. The second function is to draft intervention message for the human mediator, so the mediator could write the messages more efficiently and hopefully could help them to reduce the time consumed in the process. And the third function is experimental function, of course. It is to test whether the large language models could automatically intervene in a dispute. So our research today is mainly to discover the third function. So the method we're choosing is to do a blind evaluation among the intervention message generated by large language models and intervention message generated by human mediators. After we decide to do it that way, we notice there are three problems. The first one is it's really hard to maintain a structured intervention message from a mediator and also human mediator, because in front of a dispute you have many ways to solve the dispute. You can ask them to please calm down, understand each other, or you can ask them to provide more details. So it's really hard to maintain a structured text message so that we can compare each other. And the second difficulty is that it's very hard to introduce the requirements within the prompt, because every time we change the prompt, the result will change and the performance of the model will change. That's why we try to adopt a two-step evaluation approach. The first of course, the LLM mediator and the human mediator need to read the dispute scenarios and try to understand what's going on. And then they need to decide the intervention types need to be applied in this specific situation. And the second step is to draft the intervention message based on the type chosen in the first step. So let's go to the experiment design. First, we need to draft the dispute scenarios because there is a lack of such data set. So when we drafted the data set, we try to make it as diverse as possible. We put 5 labels. First, emotional means there are many emotional messages related to the dispute. They are complex means the dialogue is have high degree of complexity. It's really hard to understand. The third is confusion means both dispute parties are misunderstood each other and their understanding of the fact might different. The fourth one is impossible means the dispute is in a deadlock, that both parties are not here to solve the problem. They just try to argue with each other and not really go into a productive way. The last one is evidential means both parties are proposing some facts, but there is no related evidence to prove what they said. After we're using those five labels, we create a data set with 50 dispute scenarios. This is an example. We can see the dispute scenario is always structured with A and B as dispute parties, and A set, and then B, then A, then B. So it's always follow the same structure. In this dispute is about package delivery disputes. A believed that he or she received the package ordered from the store, but it was damaged. And B believed that the damage during the shipping process is not their responsibility as sellers. And this data set and the prompt we use and the code we use will be released in a few days in the GitHub link over there, and it's also in the paper. So after we construct the dispute scenarios, we start to test like the step 1 on LLM mediator and also on humans. So we choose a set of intervention types. There are overall 13 intervention types. This is taken from the Department of Justice of Canada Dispute Resolution Reference Guide. And the LLM mediator and the human mediator need to choose at most 3 types of intervention types, so that we can test whether they can understand the dispute and choose the most appropriate way to intervene. And after we get the intervention type, we do the first blind review. You can see the column in the middle. The humans can choose number 4 for the dispute. The dispute is party A asks party B to delete their picture from social media. B refused and make fun of A. So human believe intervention type number 4 and number 13 is good, means promote a productive level of emotional expression, and number 13 propose solutions that meet the fundamental interest of all parties. And the large language models think number 2, number 3, and number 9 is nice. Number 2 is help the parties understand each other's views. Number 3 is letting the parties know that their concerns are understood. Number 9 is encourage flexibility and creativity. So after the blind review, our evaluators believe the human choose the more appropriate intervention type. And at the second step, we are always using the human intervention type just to for experimental purposes, so that the intervention message is always structured in the same way. That doesn't mean we believe humans can always do better than large language models in the first step. And let's move to the second step. We need to generate the intervention message based on the intervention type chosen by human. You can see there the interlink between the message and the intervention type chosen. The human are writing intervention message based on type number 4 and type 13. So the first sentence is let's not insult each other or downplay one's feelings. And then the second sentence is B, you must delete the picture since keeping it without A's consent is illegal. So that's how a human intervenes this dispute. And when the LLM is trying to intervene, the first sentence is let's ensure the conversation is respectful. Here is the proposition, party B. How about posting key result is pretty promising. For the step number 1, intervention type, there are over 62% of large language model generated intervention type are either better or equal to human human intervention type. And for the second evaluation on the intervention message, there are 84% of large language model generated message rated equal to or better than human messages. So this is a detailed number for the first evaluation. The green button is LLM is either better or the same as humans. As you can see, the result is pretty good. And this is the intervention type, the frequency of intervention type chosen by large language models and humans. You can see LLM is pretty much prefer the first 6 options. This might be because of the paper. The large language models have certain preference among the order of the message in the prompt. But we can also see that humans are also prefer the intervention type in the prompt. So I guess that could partly explain why large language models behave that way. And if we are going to take a look at the evaluation number 2 on the intervention message, also the green and light green part means large language models is better or equal to humans. You can see the result is very promising. So let's go to the discussion part. There are mainly 4 takeaways from this research. The first one is large language models provide clarity, consistent tones, provide more acceptable solutions. Because in our research, we noticed that sometimes humans are propose something very direct. Like A, you should apologize to B. A, you should return your stuff to B. That might be less acceptable in this dispute scenario. And the takeaway number 2 is humans are actually more often misunderstood the dispute. When we are doing the blind reviews, when I do act as evaluator, I noticed there are some errors. I thought it was hallucination from large language models, and at the end of the experiment, we realized that it's actually a mistake made by humans. And the third takeaway is large language models have better performance in choosing intervention types and drafting intervention message. The result is pretty nice. The last one is assumption of human as gold standard is facing challenge. The reason why we choose to use blind evaluation between large language models and humans is try to avoid the fact that in many machine learning research we treat human choice or human written message as gold standard, and that might not be true in the future when large language models is getting better and better. So in terms of the limitation, the experiment setup is different from real-world scenarios because the dispute scenario is always the structure A, B, and mediator intervene. But in real life, it's not always the case. Mediator need to understand the context and find the right time to intervene. And the second limitation is annotators and evaluators are not professional mediator. We have legal education background, but we are not trained in mediation course. And the third limitation is it's very hard to tell which intervention is better than the other one. It's pretty objective. So the result is pretty much like the opinion of the evaluators rather than the ground truth